Hey 11s, welcome back. This is exercise 10B on arrangements on page 371 of your textbook. Now, the idea of arrangements is something that we haven't looked at yet, but it's a really cool concept that we use in counting methods. And another word for arrangements is permutations, by the way, which is why we'll use the letter P later on, but we'll skip over that for now. But the idea is that permutations and combinations, which we'll learn about later, allow you to find the total possible outcomes of a given experiment without having to go ahead and try and find every single outcome of an experiment. Now, indubitably, you've had situations where you've had to find the number of outcomes by listing every single outcome. In the last video, we talked about how that's really unrealistic in most situations. So we have to use a formula or some sort of method that helps us find it easier. Now, the number of arrangements of a set of objects is the number of different ways these objects can be arranged in a distinct order. Now, I'm making that very clear now. Later on, we'll learn about combinations in the next video, but for now, arrangements, order matters. So just like with a bike lock or a security code, wherever it is, the order matters. In other situations where the order doesn't matter, then we'll look at them later, but for now, remember, arrangements or permutations, order does matter. Now, if we're trying to complete these kind of questions, it kind of requires us to have a different way of thinking. A way of thinking that allows us to apply our understanding in mathematical contexts. So in the first example, we've got a question where it's asked, how many ways are there of arranging 4 different books on a shelf? Use your diagram to aid your working out. Now, this is, like I said, more of a thinking exercise, isn't it? So if you were to imagine how many different ways you can arrange 4 books, it's pretty straightforward. I'm going to go ahead and draw the boxes. This is the box method. You don't have to use it, but you're more than welcome to. So the box method allows us to view individual spaces. So let's say that this is space 1, space 2, space 3, and space 4. Now, the actual numbers don't matter. All we're saying is that the order does matter. Okay. Now, the way that you put down the 4 books onto the shelf does matter. If the order didn't matter, there's only one way of putting the books onto the shelf. But in this situation, we are arranging 4 different books on the shelf, so we have to try and figure out how to do that. To do that, I like to go from left to right and say, okay, well, the first box, first space, there's 4 different options. 4 different options for books we can put down. There's 3 different options for the second spot. There's 2 different options for the third spot, and there's only 1 option for the last one. Now, we didn't specify which book we're putting where. All we're focusing on is what are the possibilities. There's 4 possible books to put in the first box, 3 possible books to put in the second box, etc. And from there, all we need to do is multiply them together, because we're using the multiplication principle, and we end up with 4 times 3 times 2, which gives us 24. Okay, so we're saying that there's 24 different ways of arranging 4 different books on a shelf where order does matter. And we use a diagram to represent that. Now, you probably would have noticed that we are going down one by one. The number of ways of arranging n objects in a row is this formula here, where n is a number of objects. Now, every time we go down or go to the right, we go down or take away, the value of 1. We write this as n factorial. I'm unsure if you've seen this before. Hopefully you have. If you haven't, that's fine. N factorial just means it's an abbreviation for the product of all integers from n down to 1. So if I use an example of, let's say, 6 factorial or 6 exclamation mark, it's not a very excited 6. It just means we're going from 6 times by 5 times by 4 times by 3 times by 2 times by 1. That's it. Now, while I'm introducing the concept of factorials, there is one concept I really need to make sure that we understand. And that concept is that, remember, or for those of you that haven't learned, just take note, 0 factorial equals to 1. Now, I'm happy to explain why that's the case, but that's a explanation for a different video. 0 factorial equals to 1. That is one of the key concepts we have to remember about factorials. Otherwise, the whole factorial principle falls apart. But okay, now that we've learned how to demonstrate or use diagrams to illustrate the arrangements, and we know what factorials are, we can try to apply that in a more practical situation. So a photo is to be taken of a group of 12 students. And the question asks, how many ways are there of arranging the groups if they all sit in a row? Now, key part obviously is arranging. So if they all sit in a row, we can do the same thing. I'm going to go ahead and ignore the boxes and I'm just going to write the numbers in. We can write 12 times 11 times by 10 times by 9. You get the idea. All I'm doing is I'm writing the different number of possibilities there are for each of the different seats. Now it does say that we're arranging all of the students, so I don't have to minimize or restrict the number of seats. I just say, okay, there's 12 students, we're going to go ahead and multiply that. Now you could type that in your calculator. It would take quite some time. You end up with the answer of, now it's always significantly higher than I expect. If you were to guess how many ways you can arrange 12 different students, you'd probably guess like a lot, like maybe 100,000 or a couple million. The answer is 479,1,600. It's a ridiculously large number, but we could put that all in the calculator, or we could just write 12 factorial. And so that's why we use the factorial system. Sweet. Now, sometimes we wish to arrange objects but not use all of them every time. So just like how I said earlier, what if there were 12 students, but there were only 4 seats? And then we were restricting something, aren't we? So in this situation, suppose that we wanted to find out how many arrangements there are of the letters A, B, C when taken in pairs. The possibilities we know are AB, BA, AC, CA, BC, and CB, 6 in total. We can use a particular formula to calculate these permutations without having to write them every single possibility out. Now here's the formula, and it looks really gross, it's not as bad as it seems. In general, the number of arrangements of n objects in group size R is given by this formula here. So a couple of things, while you're writing this down, it's very important to write down. N objects, so the number of objects, and R is the size, or group size, sorry. So the formula says, and we use this notation here just to show what we mean, NPR, or the number of objects, P, the group size, equals to the factorial of the number of objects divided by the number of objects, take away the group size, and then factorial of that value there. So let's go ahead and try and apply that into our question here. So we need to find the number of 4-digit numbers that can be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we could ignore the permutation formula and just go ahead and try and solve this by saying, okay, there's 9 digits that are possible in the first one. There's 8 digits. Oh, my apologies. There's 8 digits possible in the second spot. 7 and 6, which gives us an answer of 3024. That is a possible option, but if we try to use the formula, it would also work. So let's go ahead and say, okay, n. Well, I know that n is the number of objects in this situation. How many groups are there? Sorry, not groups. How many objects are there? Well, I know that there is 9. I also know that my group size, or the number of digits that can fit into my 4-digit number, is, of course, 4. So I'm going to go ahead and write NPR. Instead of writing n, I write 9P4. Gives me 9 factorial divided by bracket 9 minus 4 factorial. You put this in the calculator, or you can just solve it by hand, doesn't matter. 9 over 5 factorial, which ultimately gives you the same value of 3024. If you want to try and answer question B, it says, well, how many can be used more than once, if each digit can be used more than once. So what's the difference? Well, the difference is if each digit can be used more than once, well, it doesn't matter. We can just say that there's 9 times by 9 times by 9 times by 9, because in every slot there is always going to be 9 possibilities, which obviously is the same as 9 to the power of 4, which gives me an answer of 6,561. And you can imagine there's more possibilities available if it doesn't matter if you repeat digits, does it? Sweet. Last concept, I know this video is getting quite long, but last concept we're looking at is a restriction in values. So the question asks how many different, and we're going to go with the same theme of digit numbers, how many different even 4-digit numbers, and we'll go ahead and highlight that part, it's very important. Even 4-digit numbers can be formed with the digits 1, 2, 3, 4, 5, 6, 7, 8 if each digit may only be used once. So in this situation, we're going to go back to the box method, right? Because restrictions mean that the permutation equation, or the formula, sorry, doesn't work as well. Let's focus on the restriction. We work with the restriction first because it typically makes it a lot easier to answer. So we have 4 boxes that need to be filled, right? 4 boxes because each and every box represents one of the digits of the code. Now the most important part, the key restriction here is even. So I'm going to go ahead and focus on the fact that there are 4 even numbers, 2, 4, 6, and 8. And our code must end in one of those numbers. So there are only 4 possibilities for the last digit. Now we know that the number of choices as I go from left to right is reduced by 1 each time. Just like in these boxes, not that box, sorry, in this box over here, or in this value, this equation over here, we can see that as we go to the right, as we go through it, every situation results in one lower value, apologies. So with that in mind, I know I can just work backwards. So working backwards from a restriction means I've got 4 in the last digit, 5 in the second last, 6 in the third last, and 7 in the first one, which means that I can multiply them, which gives me a value of 840, which means that there are possible 840 options that are even using a 4-digit number restricted from 1 to 8, where each digit may only be used once. Hopefully that makes sense. I know it's a lot of content. Make sure you apply understanding in the practice questions and let me know if you have any questions.